So jumping lab. So most people, eventually we had that kind of iterative process, came up with a good objective that was just, again, very simple, like something like, what is the relationship between a person's height, calf circumference, weight, and their ability to jump vertically. And then most people came up eventually with some reasonable hypothesis. And then we look at the data, and the next thing is like, what does the data say in terms of whether it supports our hypothesis or not? And that usually requires a little bit of work. And so that most, 1, 2, 3, 4, 5, there's still 6 people who did not actually turn that in, that initial analysis, which, and if you're one of those people, I'm not gonna like publicly say it right now, but you really wanna try to keep up. And you are gonna, the more you don't turn things in, and again, even the stuff we're doing today builds on the stuff that, this initial analysis. So I keep reiterating, but it's because it's really important to not just get behind and so you can't dig yourself out. So, and then the people who did do the initial analysis, some people did awesome. And then a whole bunch of people, it's pretty clear, don't have, need to work on their idea of graphs. So let's look at this. I'm gonna show some of the stuff that people turned in for their initial analysis right now. I'm gonna share my screen here. So here, this is somebody's initial thing. They have their weight and the jump height, and this is beautiful. This is kind of what you want it to look like. This is a nice graph. This has the x-axis is the independent variable. The y-axis is the dependent variable. They're saying what the units are. They have 40 to 45 to 50 to 55 to 60. Every 2 of these divisions is equal to 5 kilograms here, or every 1 division here is equal to 5 centimeters. So it's all regularly spaced. Then they put all of the data points here, and then you can look at it all, and it's like, it's pretty freaking random. If you try to figure out what's the best fit line where half the dots are above and below, it's basically a horizontal line.
Okay, so if there's no correlation, it's a horizontal line?
Yes.
Okay.
Right, a horizontal line means that as the independent variable shifts, the dependent variable doesn't move in any predictable way. It doesn't go up or down. Right, so if it was a positive slope, this would be a positive correlation. The higher the weight, the higher the jump. A negative correlation, the higher the weight, the lower the jump. If it's a horizontal line, it means the jump really doesn't seem to have any predictable relationship to the weight. So in order to actually make sure that these dots are meaningful, it actually, and when we're doing analysis using these graphs, you need to make sure that you make your axes regular like this, where, I'm going to show you a bunch of examples of people who are just kind of like random, like kind of pulling their axes out of out of who knows where. Like here. There's a couple of things wrong with this one here. One is 0 to 5 to 10. This is all of a sudden, this is another 5, but now we've gone up 2. And now, okay, another 2 is 5 centimeters, but now 1 is another 5 centimeters. It's like completely random. It's like, what, you know, this is not really helping us. You know, this axis, on the other hand, is all right. Every one of these is 5. This person did not give me units, so there's no weight in kilograms or height in centimeters. So we're still missing the units here, but at least the x-axis is regularly spaced. And then this line here, I'm not quite sure where they came up with this, because it's completely ignoring all of this. You know, again, if you look at kind of weight versus height, there doesn't seem to be any real major relationship at all. But again, this idea also that the axes have to be regularly spaced. Let me see which other ones I got here. This one, oh my God. This is just, I'm not even, yeah, I mean, I don't know what's going on here. It's like 0, 17.5, 50. It's like, what the heck is this? This is like 9, 17, this, and then this is like not even close to being something that, this would be like if you asked like somebody to like paint a nice painting to hang in a museum, and they like gave you a little, I don't know, a scribble or something. This is totally just, what do you call it? Phoning it in or something. This is, you need to make sure you take this seriously in terms of analyzing data. Don't think like, oh, I put some dots there and he'll think it's fine because it looked like I did something. I look at this and I'm like, it looks like you don't care. And you're not going to be able to really draw conclusions if you don't responsibly plot out the data. And if this is somebody who does not have a lab book yet, you can still, you know, use a ruler and mark little things to make things regularly spaced. You know, so if the excuse was, well, I didn't have my lab book yet, lab notebook, and there's no graph paper, you can draw graph paper. Take a little bit, takes a few more moments. But this saying the data does not support my hypothesis, you know, this, you know, you can't tell from looking at this. So just kind of putting that out there, like compare this to the first graph that you saw, which was kind of just a well laid out, you know, responsibly made graph. Let's see. This one, this is another, oh, this is another pretty one. So this is good. Again, I'm not just showing the ones where people like did ugly graphs here. Let's do, this is a pretty one. Here we have a really nice thing where we have regularly spaced units, 30, 1, 2, 3, 4, 5. So it's 2 for everything. Like if I annotate again, I can draw, we have 22, 24, 26, 28, 30, 32, 34, 36, 38, 40. So this is all regular. Height, this is now by ones, 51, 52, 53, 54, 55, 56, 57, 58, 59, 60, 61, 62, 63, 64, 65, 66, 67, 68, 69, 170. So here the units are nice and regularly spaced. They spread things out so the points take up the whole graph, which is nice. So that way you can really tell if there's a nice slope or not. Here, this line, this best fit line really does seem to be a good approximation where the weight of the dots is lower here. They seem to be higher up here. So again, this is a nice looking one. This is what you want. I need to clear. Stop to annotate. This was another good one that we saw. Again, ones where the units are all over the map. Here's another one. Oh my God. Here. Okay, so if you look at the dots on this one, it's like this is 20, and you know they are using little tick marks for like 21, 22. Actually, it's not even clear. But if you look, like how many tick marks, it's like 1, 2, 3, 4. There's 5 tick marks in this one group of blocks. There's only 2 tick marks. It's like how far it is to measure a centimeter keeps random. Is it this far or is it this far? You know, this, you need to make sure if you're going to use these graphs to actually analyze and interpret data that you have kind of solid, regularly spaced axes. You know, they did have the units here, which is good. But again, you can't just kind of make up how far, like, you know, let's make it really squished and then less squished and more spread out. You have to have a very regular amount. Like if one box is 1 centimeter, it always has to be 1 centimeter for that particular axis. This one again, if we zoom in, it's like even if you don't have graph paper, you need to then use a ruler or something. You can't, if you go from 5 to 10 to 15 to 20, it's totally elastic. It's totally like, you know, up to their artistic, you know, muse at the moment, how far you're going to go for 5 kilograms. Same thing here, where they even have lines. You could have used the vertical lines, but here 5 to 10, 10 to 15, 15 to 20 is just kind of random. So again, this is another one, 5 to 10, 10 to 15. It's all kind of random. All of a sudden 40 to 45 to 50 to 55 takes as much room as just 5 to 10 over here. So oh, I see cat. Are there questions about, you know, again, this is the beginning. I know some people get out of their math or other classes, and you know, this is something though that another thing, in addition to the chemistry, kind of basic working with numbers and graphs is going to be something that we're kind of assuming is kind of a skill that we're using to build upon. So if graphing is something, if what I'm saying was like, oh, I understand, then that's great. If you're still kind of confused about why we care, you know, you need to talk to me, office hours, or whatever, or talk to the tutors. But actually, we're going to be doing a lot of data analysis. The lab part is a lot of the skills we're learning are how can you responsibly draw conclusions from observations of the real world. And a big part of that is, drawing graphs and interpreting them. And you're not, we're going to be using Excel today even, where it spits graphs out at you. But if you're just using a computer program to do something that you don't actually understand well yourself, you're not going to be in a good position to really understand what's going on or to know if something's going wrong. So that's why I had you do a graph by hand, is I want to make sure that you actually understand graphing and relationships between X and Y axes and all that before we start having a program spit out graphs. Are there questions about all of this? Comments, questions, otherwise? Does it make sense? All right, so it's 11. All right, so what we're gonna do now is do the next stage of this lab, which is gonna be looking at the complete data set of 3 different labs. So let's look at this now. All right, where is it? There it is. Module. Okay, I'm going to share my screen again. Okay, zipping down to the jumping lab. So now I'm in the jumping lab module. So we did the doing the jumping lab already. We submitted the PDF of the initial jumping lab discussion. What I am now doing is I am publishing. There's 2 new things that are now going to be visible for you in this jumping lab module. And this first one here is continuing analysis of the jumping lab. And here it says, here is the compiled jumping lab data from 3 different sections. Be sure you download and open up this file in Excel. If you open it up from within a web browser, you're not going to have the ability to properly view and edit. So when you are going to do everything that we're going to be talking about, you need to make sure you download this onto your desktop on your computer and then open it in Excel, the native program that opens it. A mistake people make is they open it up, as a link inside the web browser, and then the web browser has these preview programs, but it doesn't have, it's not the full program. So, you'd click on this, there I've just downloaded it, and now I can open it up. So I'll show it to you in a few moments. It says, use this data to revisit your hypothesis and see if your initial conclusions that you made from looking at the single class data still hold up. Sometimes having a small group of subjects and then expanding it, sometimes it just confirms what you already found, but sometimes having a larger group of data, shows you different things. It might show, like, it didn't look like there was anything going on with the smaller data. It was too random to really tell, but now I really see some pattern happening. So see if it's still, whatever your initial conclusions are still your conclusions. And then, regardless of your hypothesis, make sure you analyze the data and look for trends regarding all the independent variables. In fact, I'm going to go edit here. I'm going to actually, this is something people, I'm gonna highlight this, bold it. I'm gonna give it a background color. Look up, let's make it yellow. Let's make it bigger font. People, save. So for whatever reason, people keep forgetting, even though I try to say this in many different ways, they'll turn in the jumping lab just with wait and say, I'm done. It's like, what I want you to do is look at your initial hypothesis, but then once you're done with that, continue on and look at the stuff that wasn't your hypothesis, because you have the data. Sometimes what is interesting in the data is not what you were originally looking for. So even if height was not part of your original hypothesis, you should still look. Is there a correlation between height and jump height? Even if sex was not part of your original hypothesis, which it probably wasn't because that was not one of our original variables, we have it recorded so you can analyze, like, what was the average height of the male jump versus the female jump or something. So use this information to look at other relationships that might not have been. So in your discussion, you'll be able to talk about not just your hypothesis, but everything else as well. There's 2 videos on using, I'm going to go over Excel in a few moments with you all. But Tina, teaches the afternoon section. She made a little thing on graphing in Excel here. And then yesterday I made another one that goes into kind of some more elaborate ways to plot out graphs and do different types of data on the same graph and sort data and do little tables and things. So these are both here for you to look at. I'm going to go over stuff, but then you can go and watch these as well to help you if you're not comfortable with Excel. Because you are going to be doing analysis in Excel. Like this next part, there's too much data to do it by hand. It's so much faster and easier if you're using Excel to spit out the graphs and do the curve fitting and all that. So.
Professor Egger, for the, like last time for the Chem Review Lab, we printed out the Excel graph. You want us to, after analyzing, you want these graphs in our notebook as well, right?
Absolutely.
Okay.
So. Yeah, in the chem, in trying to make sure that we are keeping up with, I wanted to make sure you're getting real-time feedback for the jumping lab. I have not finished grading all of the chem review labs, so I will be getting you more feedback on them. Some of them are looking good. Some of them are missing quite a bit, like, even have, paste data here. It's like, you shouldn't have turned it in yet if it still says paste data here.
And for sorry to interrupt you, but for the actually, you know what, I forgot. I'm so sorry. I completely lost my train of thought.
Okay, so let's look at Excel briefly. So let's first by a show of hands, or how many people have never used Excel? Is anybody here who's never used Excel? Oh, I'm so happy. This is changing. Like when I first started using Excel to analyze stuff in this class, I'd have like half the class didn't know how to use Excel. If you are not, and this is particularly kind of messed up in this COVID time, because normally if there's someone who doesn't know Excel as well, I just have you sit next to somebody who's like an Excel power user, and then they can help you as you're trying to work through things. But obviously that's not so much of an option now. But knowing that you all have a basic understanding of Excel is going to make this way easier for me because I don't have to kind of review over as much stuff. You know, again, things to remember. You know, every cell has a unique address like B2, C2, B3, C3. There's this formula bar here, which is always important to pay attention to. That way, if you want to know what's really in the cell, you don't know unless you look in the formula bar. What kind of things can go into a cell?
Numbers?
So one thing is numbers, exactly. And if you put a number in there, you know, I could put in 2.5. If there is just a pure number there and I click in there and I look on the formula bar, I'll see it's just a number, that it's not anything more complicated. You are able to tell it how to format that. You know, you're going to want to make it in the most appropriate format. You could say, I want it to be dollars, in which case it would look like this. You could say, I want it to be percent, in which case it would be like that. You could say, I want it to be rounded to 0, you know, to no decimal points, in which case it would actually probably be a 3 because it would round it. But if you want to know, if you saw a number, anything like this, if you clicked in the box, it would just say what's really in there is just the number 2.5. You know, and you can just format the cell to say how you want that to be displayed. What other things can we put into one of these boxes? Into a cell?
Equations and solutions.
So formulas or equations. So formulas are, so if let's say we were doing like, again, we're not going to have a lab party because we're never going to be in the same room. But let's say we're in the parallel universe where we're actually going to have a lab party, you know, and we have like, you know, the stuff you're going to buy, the price, the number, and then the total. And we'd have, you know, pizza, and it's $15 for the pizza. We need 3 pizzas, you know, and that's going to be, you know, okay, that's going to be $45 for pizzas. And then we're going to have beer. And yeah, we need to have a reasonable beer. So let's say it was, you know, reasonable beer is about like $10 a 6-pack now. Let's get like 6 6-packs. There's like $60 worth of beer. You know, so if you're making a, you know, and then we could have a sum, you know, so if you're making something like this, you could just do the math and say, well, 3 times 15 is 45, 6 times 10 is 60. But, you know, computers are really good at math. Plus, this means if we decide, well, actually, maybe we need an extra pizza, or let's go with a cheaper beer, you have to recalculate things all manually, which is a pain in the butt. So instead of putting the actual answer in here, we can just put a equation. So whenever you use a formula, one of the things people go wrong with formulas, it always has to start with an equal sign. So it's always equals, and this is just going to equal, if I'm going to look at what this should be, it's going to equal whatever the price is, which is in B2, is going to equal B2 times whatever is in here, C3. And as soon as I hit return or enter, 45 will show up in here because it's going to do the math. But if I look in my formula bar, the formula bar will say what's really in there is B2 times C2. So that's why you always need to check your formula bar. Like if I put my mouse and check, it looks like there's a $45 in here, but what's really in there is a formula. So if you're ever not sure, is that just an actual number or a formula, just click in there and see what shows up here. If you want to repeat the same formula again and again, but just slightly different, if you float the mouse over the corner here, you can get this little plus sign, little cross. And if you hold the mouse down while you have this little cross on the square and pull down, it'll just copy the same formula down. And you'll see in just a few moments, that's going to be critical for you all. You know, because for instance, like BMI, you want to calculate BMI, you don't want to have to write the formula again and again and again and again and again and again. What else? The other things you can put in a cell is a label. I recommend when you're doing Excel spreadsheets for your own data that you make sure you label things so you can look at it and keep track of what's what column is what. It'll help when you're sorting stuff as well. So what I'm going to do now is go to Excel. Again, let me look at our time. Or maybe yeah, let's take a short little break. I've been talking. We've done all this. All right. So what we're gonna do now is I am just gonna kind of walk with you through some of the ways to approach the analysis of your jumping lab data to look at both your own hypothesis that you need to analyze. And then, like I said, also look at the other variables as well. You're going to have to make graphs, which you're going to print out and put those in your lab notebook and then integrate them into your discussion to talk about what does our data have to say about this original question, this original objective to figure out what is the relationship between a person's height, weight, and or calf circumference and their ability to jump. So if we were all sitting together, in front of computers, I would normally, we'd all kind of do this together and make sure everyone's on the same track. I don't think it makes sense in this online version to do that. So instead, what I'm going to do is just kind of move along and show you kind of how to approach it. And there are those two videos, the one from Tina and again, the one that I did that is up on the module. So you can go back and see the kind of things I'm talking about. You can also look back. I'm going to put this, the stuff we're talking about now is also going to be up on the module as, YouTube of our jumping lab. So that's going to be up there. If you have questions about the details, you're trying to do it and you're getting stuck, just ask. You can email me. I can help work with you during office hours and help guide you through how to use Excel. So, but I don't think it makes sense for us to all type on the computer at the same time because it's just not practical for what we're doing. So it's 11:44. So for the next half an hour or so, what I am going to do is basically we're going to kind of go and just look at all sorts of cool ways that Excel helps you analyze data. give you ideas and inspire you to do your own analysis once I'm done with all my talking. And before we tie up our day, I'm also going to also talk a little bit about the osmometer lab, so you have a sense of what's expected for your objective and hypothesis for Thursday. So here we go. I'm going to open up the file that you all have access to. Hold on, I gotta get it. Give me a second here. Dooby-dooby-doo. Dooby-dooby-dooby-doo. Here it is. All right, I'm going to enable editing. All right, I'm going to share my screen with you all. And you should all see the data here on the screen. If at any point as I'm going through this stuff you have a question, please do stop me. I'll do my best to clarify. The way this is set up, you know, this is actually data from 2012. This is 3 different sections. I color coded it. The orange was from the morning section, would be like you guys. You know, orange is like, you know, at the dawn, you know, the golden sun coming up over the horizon. Yellow was the afternoon section, kind of, you know, the yellow of the sun midday over in the sky. And then the blue is the data from the night section, which is supposed to be kind of midnight blue, is the nighttime. So, but that's all the color coding here. It's just, these are 3 different classes. So this is like 3 times as much data. One thing you're gonna notice when you get this is you're gonna see that I deleted the BMIs. The reason I did that is because people, if people tend to do the math badly. So rather than having you have a bunch of BMIs that other people wrote and put in there and that a lot of them are wrong, we are gonna have Excel do the math because it is so much better at, in fact, let me, oh, wow. Hold on, stop sharing. I'm gonna reshare. I'm trying to make it look bigger on the screen here. Yeah, that's looking a little, I think, does everybody have a good view of this here now? Yes? Yes, no?
Yes.
All right, so for BMI, I can just, in fact, I'm gonna zoom in here a little bit to make it easier to see for you all. I'm going to view, I'm going to zoom, a zoom. I can put a formula here for BMI. What is the formula going to be for BMI?
So in kilometers over height squared.
So say that one more time.
The weight over height squared.
So the weight, so let me, so BMI is the weight, and what is the units of the weight?
In kilometers.
Kilograms.
Okay, kilograms.
It's gonna be kilograms. Remember, kilometers is length. Kilometer is like 2/3 of a mile. How much, just to remember, how much does a kilometer weigh and what most people are more used to? Kilogram is about how much in terms of weight?
2.2 pounds.
Yeah, about
So,
2.2 pounds.
Like a can, maybe. A can of beans or something.
So it's going to be weight in kilograms divided by height. And what's the unit of the height?
Meters.
BMI in meters,
Square.
quantity squared. So this is what I want my equation to be. If I look at my graph, I have the weight. This is going to be in, this is in column B. Their height is in column C. The weight is in kilograms in terms of our data sheet. What did we measure the height in our sheet?
Centimeters.
It's in centimeters. So that we're going to have to deal with that. The fact that the numbers in column C of our graph are in centimeters, but for this formula, it has to be in meters. So what is this formula going to actually look like? Formulas always have to start with an equal sign. If I look at the first, the first person has their weight is in B2. The first person has their height in C2. What is the formula going to be for the BMI for this first person in terms of?
Over C2.
Say it again.
E2 divided by C2.
B2/C2.
So it's going to be B2, but definitely not just over C2. That would be, first, it's in the wrong units. It's in centimeters, and second, it's got to be squared. So B2, which is weight in kilograms, that's what it's supposed to be. How do I convert height in centimeters into height in meters?
Divide by 10.
Multiply by 100.
Divide by 1,000.
Divide, sorry, by 1,000. Exactly.
By
100.
100. It's going to be dividing by 100, right? So, and again, you do that kind of sanity check. If somebody is 150 centimeters, if I multiplied times 100, that would be like 15,000 meters. No, there's no way. That's ridiculous. So it has to be divide. And going from centimeters to meters, that's 2 hops. If you remember what we talked about last week, you can just think about going from centimeters to meters, just how many hops, how many changes on those orders of magnitude. So it's going to be C2, but divided by 100. And I'm going to have to put it in parentheses because I want it to happen with precedence over everything else. And to make it squared, how do I do powers when I'm doing computer formulae?
An asterisk?
Well, asterisk is how we do multiplication. This is like.
Oh, I thought that was for doing a power. Never mind that.
The little carrot top.
It's a little caret. So you could do it like that. This is how you would do squared. If I wanted x squared, I would say x caret 2. So that's how you do powers when you're doing these equations. In terms of precedence of operators, if you remember in math, you're just from like elementary school, my dear Aunt Sally. Remember, it's first you do parentheses, then you do powers, and then my multiplication and division from left to right, and then addition and subtraction from left to right. So this right here actually is going to work. It's going to do this first, then going to do the power, and then do the division. If you wanted to, you could also put this in parentheses. It's superfluous, but it makes it a little clearer that that whole thing there is in the denominator. But this is my equation. This is the equation that is going to give me the BMI. It's going to take the height in centimeters, turn it into meters, square it, and then divide it into the weight. So are there any questions just about this formula here? All right, so then I'm going to share my screen again here. And I'm going to just do it. I'm going to go, okay, my BMI is going to be equals And it's going to be B2 divided by parentheses C2 divided by 100 to the power of 2. I hit enter, and ka-ching. Here you see that the BMI says 21.4. It did the math. If you look up here in the formula bar, though, does everybody see that? The formula bar is actually the actual formula. So you're like, what's really in this? Even though it says 21.4, that's the answer to the formula. What's really in that box is this formula. That's what I was talking about. Pay attention to the formula bar to see what's really in the cell, rather than, if you're not sure, is it, if I click in the height box here, I look at my formula bar, it's like, oh, it genuinely is 162.3. It's just a number. It's in the box. Right? If I click in the weight box, if I look in the formula bar, it's just the actual weight. But if I click in the BMI, it's like, oh my God, there's actually a formula in there that calculates out to 21.4. I have to do the same BMI formula for all of my subjects. And rather than type out the same thing again and again, Excel makes it easy. You highlight the cell that has the formula that you want. You move your mouse. You can see in the very bottom right-hand corner of this box, there's a little square. I put the mouse over it till it turns into a little black plus. It's currently a little black plus. I click on my left mouse button and I just drag. I keep the mouse button down, I drag. Basically now everything that is in there, when I let go of the mouse button, and I'm gonna get my zoom back now into you can see all the BMIs have calculated and are now in there appropriately to the data for that particular row. If I look at the formula for BMI for the next subject, it's B3 divided by C3 divided by 100 squared. If I look for the BMI for the next subject, it automatically made it B4 divided by C4 divided by 100 squared. So it automatically does the appropriate shift. So there they all are. What I typically do at this point is I fix the colors because it keeps it pretty and also makes it clear if something gets messed up when I'm sorting. So I'm going to select these ones that should be yellow, and I'm going to go into home and I'm going to make them yellow. I'm going to go pick these ones that should be blue. I'm going to go into my little paint bucket and I'm going to make them blue. So now I have all my data here and the BMI has been calculated in its part. I cannot overemphasize how important it is to save your work. Computers crash, you mess things up, all sorts of things go wrong. So I'm going to go into File and I'm going to save. So now, no matter, even if, if the power, in fact, it's a good chance that with all these fires and stuff, you're going to be working along and all of a sudden you're going to have a freaking blackout or something and your computer's going to turn off. So keep saving. So worst case, you just will go back to where you were when you last saved. Other things. I can now try to graph things. So what I'm going to do now is I'm going to show you a few different ways to approach graphing things and looking to see if there's a correlation. And then I'll show you more complicated graphs, and then I'll show you how to sort things and how to get averages and things like that. So, but the first thing you need to do is just get all your data kind of set up with the BMIs. So when you get and start looking at this on your own, the first thing you're going to do is calculate the BMIs in here and kind of save this as your kind of starting point. Are there any questions about how to do these formulas and just get a BMI in there? Okay. So making plots, making graphs. There are two ways to do it. One way is you can select things and insert a graph, and Excel will do its very best to try to guess what you wanted to graph. And sometimes it does a good job and sometimes it does not. For making bar graphs, I highly recommend letting it do the kind of formatting and stuff. For scatter plots, I usually assemble them myself, although you don't have to. So like one thing, when you're selecting things, if you just hold down the left mouse button and drag, it selects things. If you hold Control down, you can select more than one thing. You can add to your selection. So that's important to realize. Holding the Control key down will let you select things that are not all connected. Otherwise, if you're not holding the Control key down, it'll release the last selection and start a new selection. This is going to be important to understand how to either select things or how to select things and keep adding. One way, in fact, in Tina's little video, she does kind of a more straightforward way to do a graph. Like if you wanted to graph their weight versus their jump height, you could just select the weight, all the weights of all the subjects. Let go. I've got those. Now I'm holding the Control key down so those don't get deselected. I'm selecting all the jumps. So now I have the column with the weight selected, the column with the jump selected. I don't have the names. Don't put the names in there. If you put words in the graph, it makes it choke. Then I could go up into Insert. I'm at the very top here, Insert. Down over here, I have all these charts. I'm always going to pick the scatter plot. If I'm making a scatter plot, it looks like little dots. I always am going to pick the scatter plot that does not have the connector lines. You don't want to connect the dots. So there it is. I have this thing here that has their heights on the bottom, their weights here. It actually did what we wanted. A few things where we need to play with this before we're actually good to go. One is, obviously you need to label your axes. So I'm going up here, add chart element, axes titles. I'm saying my primary horizontal axis is going to be their, oh, this was weight, right? This is their weight in kilograms. You know, I have to label my y-axis, so I'm going to add chart element, axis, primary vertical. This is going to be their jump height in centimeters. So I got that going now. Next thing, notice that the data is all kind of squished over here. Nobody's weight was 20 or 0. So in order to spread my data out and make it fill the screen, I can just go down. I'm floating over the x-axis. I'm doing right click. Right click gives you context sensitive menus. I can just say format the axis. And I'm going to say the minimum is going to be 40 instead of letting it go automatically started at 0. I'm going to hit return there. Now I have the data spread out much more reasonably. You know, so now my data points are filling the screen. I've got my labeled axes. That's all good. Now, to see if I do my best fit line, I can let this calculate the linear best fit. To do that, I just have to select the dots. If you just click on the dots, you'll see just representative dots get selected with these little mouse ears on there. And now what I typically just rest over the dots. And again, if you do the right click of your mouse, the right click is always context sensitive menu. And one of the options is add a trend line. And then you can do different kinds. For a linear best fit, obviously you're gonna use a linear trend line. So there I've got my linear trend line. And this would be something that I could print out and use in my data. And I could say like, all right, I've got weight versus jump. And if I look here at the linear best fit, does it look like there's really much of a relationship between the height they jump and the weight, their weight?
No.
Slightly positive correlation. Slightly, just a teeny bit.
You know, I would say it's so small. Plus, you look how spread out the data points are around it. I wouldn't really trust it to be meaningful at all. And you can actually add in, if we go back into the trend line, you can, this little R squared, this is giving you how much can you trust that this line is actually a meaningful fit, and it's basically telling you it's really not that useful. So this is one way. This is kind of an easy way to make a graph like this, although it doesn't give you a lot of control over things and you can run into trouble. So I usually don't do it this way. So I'm going to show you how I usually make the graphs. The way I usually make the graphs is I don't let it decide what I want to do, which means you have to select something far away from the data. If you are selected in the data or near the data, Excel will try to be your best buddy and predict what you want it to do, and it'll make the graph and it'll look like crap, right? In fact, I'll just show you. I'm going to accidentally leave my selection inside the data here, and I'm going to go into insert a scatter plot, and I get this thing that is absolutely meaningless. It's like pretty. It's like, you know, people will like print this out and put it in their lab book, and I'm like, but it doesn't mean anything. Or sometimes they'll think they're, you know, they'll put something like this and they didn't realize it made a weird graph, and they'll say, oh yeah, this x-axis is the weight. And I'm like, nobody weighs zero. They'd be floating up in the air. They're ghosts. You know, so you look at a graph and it doesn't make sense. Something went wrong. So get rid of it, start again. So I'm going to select outside of my data. I am now going to insert a graph, my scatter plot. And now, well, actually that's still not quite right here. There, let's insert my scatter plot. There we go. And if you look here, it's a tabula rasa. It's completely blank. There's nothing in there, which means first step, we have to tell it what data do we want to graph. So for instance, let's say I want to graph height versus jump. So there's a few different ways you can select the data. If you go up here, there's a select data, and you can click up there and lets you select the data. If you're just inside here and you do the right click context sensitive menu and select data, there's many ways to get to the same end when you're in Excel. So I'm going to add a series. So a data series is a collection of X and Y values that it's going to graph together. So if I'm going to graph height versus jump, I'm going to have to add a series. I don't even have to give it a name because I'm only doing one series for my first example. I could just, for the X values, this little arrow dealy bumper here, I'm going to click on this. You all see this little arrow where it says select range. I click on that. it now lets me select what are all the data that I want for my x-axis. It's going to be all the heights. I'm selecting them all and hitting enter. And I can look, I want to double check. Oh, it says my X values are C2 to C79. You know, C2 to C79. It's like, check, that's what it should be. Y values are going to be the jump heights. So again, I click on that little arrow dealy bopper here, and I'm going to select all my jumps and hit enter. And again, I double check F2 to F79. You know, those dollar signs you don't have to worry about now. It has to do with absolute versus relative addressing. So then I hit OK and OK. And there it is. There is the data, the height versus jump. Just like last time, I'm going to have to make sure I add my axes titles. Primary horizontal axis here is going to be the person's height in centimeters. Primary axis title, primary vertical is going to be the jump height, also in centimeters. And then I also see the data is all squished. So I'm going to maybe starting at 145 or something. So all this is just space. It doesn't really, it makes it hard to see what's going on with your data if it's all squished. So I'm going to go onto my axis. I'm going to do my context sensitive menu here, my format axis. And I'm going to say, let's start around 145 instead of at 0. And ka-ching, there the data is now spread out more pretty. And then I can also do my select the data, add a trend line. And here I'm actually seeing something a little more interesting. Does this seem like there's a relationship between height and jump height?
Yes, positive or directly proportional.
Exactly. This looks like kind of a nice positive or direct correlation here. So again, this is something that you could print out and be part of your discussion. What I'm going to do now is show you how you can kind of sort data and you can get deeper in. Like one of the things that's always interesting is sometimes the story isn't quite as clear as you think. Like here, you might just say, all right, that's awesome. Height is predictive of their jump height. I guess I got an answer. What I'm going to do now is we're going to like look at a similar graph, but we're going to separate the subjects between male and female and see if there's anything interesting that happens. And this is also going to be a way for me to show you how to do more than one data series on the same graph. So what I'm going to do now, and one thing I should say, if you rearrange the data, you want to be on a different sheet. If I rearrange the data, this graph is going to change because these dots correspond to the cells. They're not connected to the actual data point. So if I rearrange stuff in here, this chart is going to change. So what I'm going to do is I'm going to just copy my whole data sheet here. I'm just saying copy. I'm going to go to another sheet, data sheet 2. I'm going to paste it here. And that way I can mess with this and it's not going to affect the graph that I made here on this first sheet. So in fact, I'm going to do another one. I'm going to paste another one here so I can play around with this one as well in a few moments. So for this one here, what I am going to do is I am going to sort the data so I can easily look at just men or just women. When you want to sort data, you always need to make sure all the data is selected. If you don't select all the data, it might just sort one column and disconnect it from the rest of everything. So everything is selected. And then I can go up into this top bar, data. Right here, you all see that data and sort. And I can tell it, what do I want to sort by? I'm going to sort by sex because it looks at this top thing and assumes it's the labels. I'm going to sort by sex. Okay. And now, if you look, all the females are at the top because F comes before M in the dictionary, and then all the M's are together. This is going to make it really easy to just grab the heights of the men or just grab the heights of the women. And what I'm going to do now is I'm going to make a plot again of heights versus jump, but I'm going to look at men separately from women. And we're going to see what happens. And you're going to see it's actually pretty fascinating. So I'm going to select a dot outside of my data so it doesn't try to make up what I want to do. I'm going to insert a scatter plot. Ching. And again, the same thing, we're going to have to select data. I'm going to add a data series. Whoop, hold on, what's going on here? There's, all right, select data. Let's add a series. The series now is going to have a name. The first one is going to be women. And the X values are going to be the heights, but just the heights for the women. So I'm going to go down all the heights, but just to 58, which is the end of where the women who have been sorted up here. And then the Y values are the jumps, but just the jumps for those exact same subjects. And again, I can double check, C2 to C58, F2 to F58, that sounds good. And now I'm going to add another series. This is going to be the men. And the X values are going to be the height, but just the heights of the men. And the Y values are going to be the jumps, but just the jumps of the men. Okie dokie, okie dokie. And here we go. Again, everything's all squished on the side. So let's format the axis and make it so the data kind of comes out here. So now, and then if I want to know which is which, I can go into my chart design, add chart element, and I can say legend. So legend just lets you say, oh, the women are the blue dots, the men are the red dots. And so I'm actually seeing something interesting. The men are all clustered up here, the women are down here. I can now add a trend line just for women. I can add a trend line by selecting the, if you ever mess something up, you can just go backtrack. All right, so here now, there we go. Now I've got the men. I'm going to add the trend line for the men. And we see something really fascinating. It's like, okie dokie. If you just look at the women or just look at the men, there doesn't seem to be any correlation at all between height versus weight. We saw that if you look at if you ignore sex, looks like the taller you are, the higher you jump. But when we do a graph like this, we actually see something interesting. What's probably happening is, we're going to talk about this more. Testosterone is anabolic. Testosterone, the same amount of exercise for a male versus a female is going to result in, stronger muscles just because of the hormones flowing around in you. Also, women, when you in anatomy, remember the epiphyseal plates. Your long bones are growing longer based upon the action at the epiphyseal plates, and at some point the epiphyseal plates close and become the epiphyseal line. that plate closes a few years earlier for women. So by the time a woman is like 18 or something, she's probably stopped getting taller. Whereas the epiphyseal plates keep growing for another few years for a guy, and they tend to end up a little taller than women on average because they have an extra few years of having their long bones elongate. So when I look at this, I'm like, yes, taller you are, on average, the higher you jump, but that's because men tend to be taller and men tend to jump higher, and women tend to be shorter and women tend to jump not as high. So, the real thing that's going on here is more interesting. So this is a way you can put more than one data series. Like you could have for calf circumference, you could have calf circumference versus jump, but just for the healthy BMI people versus the unhealthy BMI people, and separate them out. So you can play around by having different subgroups on the same plot like this. Other things you can do, like I could show you how to do a bar graph. Let me look at, I'm checking the time, we're okay. Like an example of a bar graph. Like for instance, let's say I want the average, what is the average jump for a man versus average jump for a woman? To do that, whenever you're making a bar graph, I highly recommend making a little sub thing on the side with the labels, because otherwise I can say Excel is really tricky to make the labels good on a bar graph if you don't just let it do it automatically. So I'm going to say this is going to be average jump height, average jump in centimeters. This is going to be for men. It's going to be women. So I'm making my little chart here, which is kind of, again, my little corner here. I can like maybe, I'll highlight a bit so you can see it better. So I've got my little chart I'm making here. So to get the average jump for men, I can just insert a formula. So I can go to do a formula. One of the easiest ways to insert, I just go up here near the formula bar. You can see this little f of x. That just means insert function. So I go to this f of x, insert function, and there's so many different functions. You can do so many things. For right now, I'm just going to use average. I'm going to say, okay, I want to insert an average. And now the same thing with that little arrow, I can say, which cells do I want to average together? I'm going to click on that, and I'm going to pick, whoa, I need to move that away. I want to pick the jumps of all the dudes. So it's going to grab all of those. And there, again, if you look at the formula, the average of B7 through I, well, that's not right. So something went wrong. So in fact, we know it's got to be the average of F59 to F79. So we can just actually type it in there. What was that? Yeah, so there it is. I can do the average jump for the women. I'm going to insert function, average. I'm going to pick the jumps of all the women. Okay, okay. And now I double check, and it's like F2 to F58, that looks good. All right, so both of these, this all looks good. I am now gonna select my whole little table here because I want Excel to say, this is the data that I wanna make a bar chart. And remember, we're comparing categories, you use a bar chart. So now I can go insert, and I'm getting a bar chart, and here I got it. And again, if I'm gonna do this properly, I'm gonna add a primary vertical. This is gonna be average jump in centimeters. Here I have a nice little bar chart showing on average men jump quite a bit higher than the women in the class here. So it's another way that you can play with data. You can make bar charts, you can make lots of different things. One last thing, I'll just kind of give you a sense, like I showed how we sort, so I'm on another sheet here. Remember, I'm going to sort differently. If I resorted this, I can just show you. I'll show you what happens. Look what happens to my graphs if I resort things. If I go into data and I have to pick this. If I sort and let's say I sort instead by BMI. Okay. It's like everything has changed. All these things like this date, if you look at the trend lines, everything's wrong. This graph disappeared. So it's like, oh my God, messed up. If you mess up, go to the undo arrow, undo, and this click, I'm all back. So if I want to sort by BMI, I'm going to another sheet, which I'm going to use this one as my BMI like playground. And I'm going to go here and I'm going to sort this one by BMI. Okie dokie. So now it's going from the lowest BMI to the highest BMI. And if I want to graph this, let's say I wanted the calf versus jump, but just for the people with healthy BMI, I could pick the data, calf, but only down till I hit the BMI of 24.9. Right? So then I would have calves, but just for the people with healthy BMI. So this is letting me know which subset of the data is the healthy BMI. So if I want to graph calf versus jump, but just for healthy BMI, I can do that. So are there, I've dumped a lot of stuff at you. Are there questions about all of this?
So for Thursday, how much we need to do, how many graphs?
So I would say like by next week, by Thursday, maybe, you should start playing with it. Like by next Tuesday, you should have graphs for, at least all of the main variables that we looked at. And then some of the other stuff, and definitely whatever your particular hypothesis was, you have to be able to use this data to help you reach conclusions about whether your hypothesis is supported or not. And I know that for some of you, you're going to look at this and it's like, oh, cool, I love Excel. And other of you are going to say like, holy crapola, whoa, I got to like look and figure this out. So, if you're having trouble with it, I'm happy to help you. There's lots of other resources out there as well. I got to look. There used to be people that would help at the college, and I don't know if they exist anymore. But actually, that's something I should probably look at and see if there are kind of computer resources, if there are people you can talk to in tutoring to help you figure out how to do graphing and things.
Professor, I have a question. In my hypothesis, I didn't include the BMI, and it seems like a lot of these will like necessitate having the BMI as part of it to have more accurate results. So can we modify hypothesis, or are you just saying like based on the hypothesis I had, I know that I was missing this, but now when I graphed it.
No. So one of the things that's nice to do at this point is, as you get inspired, is check things out and find the best story you can tell.
Okay.
Yeah, no, this part can be really fun because you get to explore and see what is there. This isn't just like do the minimum and stop. Hopefully you're going to get a little inspired and get curious. You get curious about, interesting. Now that I can see what's possible, let's play with this and see what I find.
Okay. Thank you.
So, yeah, no, so don't worry about this. This is not going to be due right away. because I know this, it's quite a bit of work ahead of you to just do it to do it at all, let alone if you're having trouble kind of getting used to Excel. If you're not that used to Excel, you'll be happy you're getting used to it because it's so useful. I use it for so many things. Just you go on some like adventure with some friends and you're trying to figure out like the finances at the end, and you just make a cool little Excel spreadsheet and you put in who bought what and it automatically calculates what everybody owes everybody else. You know, you're planning a party and you're trying to figure out how do I keep the total of this party a reasonable amount of money, and maybe I have to like again buy cheaper beer, and how does that affect the overall price of everything. So Excel is great for lots of things beyond just this. So before we stop, I do want to just really briefly talk about the osmometer experiment. I should be able to do this pretty quick. So next lab, there's two different parts. One part is just about demonstrations of diffusion. That doesn't need any kind of hypothesis. So only pre-lab for osmometer. You don't need to do a pre-lab for the other parts of it. And the basic idea is we're going to have this thing where we have some solute it's actually going to be sucrose. We're going to have one group that has 20% sucrose, another group that has 40% sucrose. And then we're going to put this thing in just distilled water. And this is a semi-permeable membrane right here. So what is going to happen if I have distilled water out here? I have sucrose solution in here. And here I actually have this little tube. This is connected to a tube that goes up. You know, when we start, the water inside here and in and out are about the same. What's going to happen as soon as I let this go and let osmosis start?
The water level in the tube will increase.
Exactly. Ready? Because remember, the solute draws the water. We talked about in osmosis, the water moves towards the area of higher solute. So the water is going to be moving in, and we'll be able to see the water going up the tube. You know, and by checking how fast the water goes up to the tube, we get basically the rate of osmosis. Again, this is going to be our dependent variable. We're going to be able to see how the rate of osmosis is different in different situations. If the water is going up more quickly, osmosis is happening faster. If water is moving more slowly up the tube, it's going to be a lower rate of osmosis. And then what about our independent variable? What's the independent variable?
Solute concentration.
Exactly. So it's going to be those two cases. One case where we have 20% in here, the other case where we have 40%. And it's a little more than the solute concentration because we're going to talk about this in much more detail, but we've already mentioned what actually drives the osmosis or drives diffusion.
The concentration.
It's in more than just the concentration. You're almost there.
The gradient.
The gradient, exactly. The concentration gradient, which is the difference on the two sides. Again, distilled water, what's the osmolarity of distilled water?
0?
0. There's nothing dissolved, no particles. So if I have 20% inside, I have a certain difference between the inside and outside. If I have 40% sucrose, I have a much stronger gradient, a much higher difference between the two sides. So it's this difference that is really important because I could have, 40% sucrose in here, but if I had 40% sucrose out here as well, what would be the rate of osmosis?
0.
0.
No,
0.
0.
There'd be nothing. So it's not just the concentration, it's the concentration gradient. That is going to be the independent variable, the thing we're varying. So when you are writing your hypothesis, make sure that you don't just say concentration. Make sure you say concentration gradient, because that's what's really important. It's the difference across the membrane in our osmometer. Like how strong is the difference between the two sides? That's what's going to be the thing that we are concerned about. And again, your objective is just going to be a simple question. What is the relationship between the independent and dependent variable, which, how does the rate of osmosis depend on the concentration gradient across the membrane? Something like that. It's that simple. It really is, but it's got to be a question that brings in the dependent and independent variable. And then your answer, your hypothesis should be, what do you predict in one case versus the other case and why? And that will be your pre-lab. That's all you need to do. Again, it should take you a few minutes. It shouldn't take you too long. But you want to have that ready to go. And I don't have it set up yet, but I will give you a little thing where you can just upload before Thursday morning. Please upload just a little PDF showing me that you've written down your hypothesis and your objective. And so I'll put that on. I'll put that thing to submit that just in a few moments now.